Gel permeation chromatography has the main purpose of determining the molecular weight of a compound, or more specifically, of polymers. Like any chromatography, it consists of a mobile phase and a stationary phase. In GPC chromatography, the mobile phase is THF, while the stationary phase is a packed column. This is kind of what the packed column would look like. These are the borders of the column, and inside, the column is packed with beads that are often porous in nature. These beads can be made from polystyrene and other materials like that. The THF flows through the column and will push molecules through the column. These represent a larger polymer and a smaller polymer. The larger polymer will pass in between the beads and have a relatively short path of travel. They come out of the column first. The smaller polymers will get stuck in the pores and take quite a bit longer to make it through the column, kind of as if it was going through a maze. And they will come out last. When the polymers elute from the column, they will then pass through a refractive index detector. Light is shown through a reference cell filled with pure THF, and then through the sample cell through which the sample will pass. When there is no sample, the light will pass through the THF and the sample cell, and there will be no unpredicted bending of the light, resulting in a flat signal. However, when the sample passes through, the light will refract and bend and hit the detector at a different angle, resulting in an electric signal that produces a peak. The larger particles that come out first will have a lower elution time, while the smaller particles that come out later will have a later elution time. The height of the signal is directly correlated with the concentration of the sample that you put into the instrument. This is the GPC that is in Baker Room 540. This bottle contains clean mobile phase, while this bottle is where the mobile phase used during a sample run will be discarded. We call it the used THF. Up here is where the pumps for the GPC lie. This is where the separating column is, and this is where the refractive index detector is. Over here is where you insert your sample. Now let's talk about sample prep. We have THF. Make sure that it is HPLC grade or has 4-GPC written on it. We have the polymer I'm going to use, which is polystyrene, 2 vials and caps, a micro syringe filter, a syringe, and our spatula for portioning out the polymer. GPC samples can be run qualitatively, but you want to shoot for between 12 to 20 milligrams per milliliter of polymer in solvent. Here's a picture of how much polymer I used. I added roughly 3 milliliters of solvent to the vial. Sometimes you're going to get a polymer that doesn't want to dissolve well, and in situations like that, there's only one thing you can do. Just kidding. There's other things you can do to get these to dissolve. After that, we're going to filter out any excessively large polymer particles by taking our solution and running it through the microfilter. Now I'm going to show you how to run a sample. To run a GPC sample, follow the instructions on this worksheet that's right next to the GPC instrument. It will show you how to change the flow rate and also how to switch off recycling so you can purge the instrument prior to balancing the signal. This is the syringe used for loading your samples into the GPC. I have to clean it first with a clean THF into the waste bottle, but first I should probably put on gloves. Minimize the amount of air that's in your syringe and suck up 50 microliters of sample. While the port is set to load, insert your syringe, but do not press the plunger down. Navigate to Run Control and select Run Method. After you select Run Method, this colored bar will turn blue and then it will turn pinkish purple. During the pinkish purple window, you should begin injecting your sample, and by the time the pinkish purple window is finished, your sample should be fully injected. You want to turn the knob to start right as that colored bar turns blue again. Here's the needle, and I'm going to start the run. It is blue, it is pink, insert, down because it's blue again, hold for 10 seconds. 1, and hit it back to load, remove the syringe, and we're going to clean it again just how we did before. After the run is complete, you should have something that looks like this. Let's talk a little bit about data analysis. In order to determine the molecular weight of our sample, we have to be able to correlate its elution time with its molecular weight. This can be done by running standard samples, which are polymers with known molecular weights, through our GPC, and identifying which signals each molecular weight corresponds to, and using that to create a calibration curve like the one seen here, where elution time is on the x-axis and the log of the molecular weight is on the y-axis. That calibration curve alongside these helpful equations can help us integrate under our signals and solve for the number average molecular weight of our polymer. This is what the raw data looks like when you export it from the GPC as a CSV. These columns here are found by using the calibration curve to solve for the log of the molecular weight. Over here are columns created by the helpful equations I just showed. All of these represent the integrations necessary to find the area under these signals and correlate that to the molecular weight. Here's the output for this sample for the number average molecular weight, the molecular weight, and the PDI, which is more commonly referred to as the dispersity these days. The dispersity can be solved for by taking the molecular weight and dividing by the number average molecular weight. I don't know if you guys are like me, but I used to be obsessed with chromatography. And then I realized it was just a phase. I hope you enjoy this instructional video on gel permeation chromatography.